equations with variables on both. No, wait. I'm ahead of myself. Sorry. Multi-step equations. So we've done 1 and 2 step. Now we're going to do multi-step. Okay, so we still are going to try to isolate that variable. So we want, x equals whatever number. So we're trying to get to this state. In a multi-step equation, the first step is going to be to distribute if necessary. Now, it is not always necessary. But if you see this, these are kind of small, huh? Is that a little better? Okay, but if you see this, you're going to know that you need to distribute. Okay. Step 2 is going to be to collect like terms. Okay, and we're collecting like terms on either side of the equal, so we're not crossing that equal sign. If we have like terms on the left, we'll collect those together. If we have like terms on the right, we'll collect those together. Okay, step 3 is going to be to add or subtract. And then step 4 will be to multiply or divide. Yes?
All right, this is different from the order of operations.
We're going backwards from order of operations because we're undoing.
Oh, that's only when there's something equals
Yeah.
something. When
Yeah.
the equal sign's not there,
When then you're using order of operations, yeah. So it's a little different. So it's like we start going in the correct order and then we switch order and go backwards because we're undoing things, but we still have to do some things to be able to undo other things. But these are the steps. You're going to distribute if necessary. You're going to collect like terms on either side of the equal, and then you'll be doing adding and subtracting, or adding or subtracting, and then you'll be doing multiplication or division. Sometimes you don't have to multiply or divide because once you collect the like terms and you add something, the x is just by itself. So I'm going to put if necessary in here. Okay, and it's always the opposite of what has been done.
Unlike, say, example number
here?
Second example, okay?
Yeah.
Say that x had, that's like x plus 7x. You would collect those before you distribute the 2, right?
No, you distribute first. We're always going to distribute first.
Distribute the 2, even though there's like terms within the parentheses.
Oh, if there was you mean like inside the parentheses, if it was 2 times x plus 7?
Mm-hmm.
Yeah, you could collect your like terms first.
Okay.
Yeah. You probably won't see that though. Honestly, you probably won't see that very much. You might see, you're more likely to see x plus 7 minus 5 or something like that with 2 numbers, but even then, usually inside the parentheses on a problem that you're having to solve, usually they're like this, where you just have an x term and a constant.
And if there was a number, then it would be 2.
Yeah.
Okay.
Yeah. Okay, so the first step is we're going to distribute. So I'm going to distribute that 2n and this -3. Okay, so when I distribute this 2n, I get 2x plus 2. And then I have to remember when it's -3, it's the same thing as a -3, so I have to multiply by -3. So I get minus 3x plus 6 equals 11. I don't have anything to do on the other side, so I just carry through the 11. Okay. Now I'm going to collect like terms. 2x and -3x are the same. Now this next step I'm writing in, remember you don't have to write this step if you don't want to, where you rearrange it. If you want to just collect them and do the addition or whatever in your head, that's fine. I'm just writing it down for people that need it. 2 and 6 are the same. So plus 2 plus 6 equals 11. Now I'm going to go ahead and combine these terms. And so I get -x, ooh, not red, -x plus 8 equals 11. So far, okay? Alright, so now I'm going to do the addition or subtraction. So I'm going to subtract 8 from both sides. And I get negative x equals 3. Well, I don't want to know what negative x is. I want to know what positive x is, right? So when I have this, it's the same thing as dividing by negative 1, or I can just change the signs on both. So if negative x equals 3, x equals negative 3. Okay, so here I'm going to go ahead and distribute this negative 3. Oops, that's supposed to be red. This negative 3, I'm going to bring it in, and this 2. So I get negative 3x minus 3 plus 2x plus 14 equals 15. So I have negative 3x plus 2x. I'm just going to go ahead and, hold on. So again, I have negative 3x and positive 2x gives me the negative x. Negative 3 and 14 gives me positive 11, and that equals 15. Subtract 11 from both sides, and I get negative x equals 4. Well, if negative x equals 4, then x equals negative 4. Now, just as another example, if I had negative x equals negative 2, I'm changing both signs, so x equals positive 2. So it won't always make the answer negative. Sometimes it can make the answer positive. It's just the opposite of what it already was. Okay. So you can end up with fractions. We're going to distribute, and if you remember, first I'm going to check, do these two numbers divide by this denominator, which they do. So 7 goes into 21 3 times and into 14 2 times. After I've done that division, then I'm going to multiply this 3 in. So 3 times 3 is 9. 3 times 2 is 6. Then I just have a straight distribution here. So 2 times 6 is 12, and 2 times 4x is 8x. That equals 52. I'm going to collect my like terms. 9x and 8x is 17x. 6 and 12 is 18. Now I'm going to subtract my 18. So 17x equals 34. And then on this one, I do have to do that division. I'm going to divide both sides by 17, and I'm going to get x equals 2. Okay, here we've got a fraction distributing in to whole numbers, and here we have a whole number distributing into fractions. So on this portion, I look to see if the 3 goes into the 6 and the 9, which it does. So 3 goes into 6 twice, 3 goes into 9 3 times. Then I do the multiplication, 2 times 2x and 2 times 3 to get 4x minus 4, 6. Okay. On this part, though, I should probably slide that over. Okay, on this part, though, I have denominators inside. So what I do is I look at the 15. Does it divide by 5? Yes. So if I do 15 divided by 5, that's going to give me a negative 3 times this positive 3. Does that make sense? And then if I do 3 into 15, I'm going to get a negative 5 times this negative 1, and that'll take care of that 15. Did I lose anybody? Yeah? No? Yeah.
All right, I didn't
Follow it?
I was understanding the first part, but the second part was really
Yeah, that's why I put this in here. Okay, so we're just going to look at this right here. And I'm going to take it over here just to go through it. So I've got negative 15 times 3/5 x minus 1/3. Okay. What I'm doing is, because I'm multiplying 15 times 3/5, I'm going to divide that 15 by this 5. Because if I distribute the negative 15 in, it's essentially this. Okay? And if you need to write this step out, do. So when I multiply 15, 5 goes into 15 3 times. 3 goes into 15 5 times. So when I came over here and I didn't write in that extra step, I took this 3, this negative 3, and I wrote it up here because it's going to multiply times that 3. And I took this negative 5 and I wrote it here. And that got rid of that 15. So that's what I was doing. So here now I have negative 3 times 3x, which gives me 9x. And then I have this negative 5 times 1, so that's minus 5. Or
You said negative
plus 5.
3 times 3. I thought when you times the negative and the positive, it's negative.
You're right. Thank you. Negative 9x, and then negative 5 times negative 1 gives me that positive 5. Does that make sense? Okay. So up here now I have that negative 9x plus 5 equals 29. Okay, so better? So if you want to write this step in, please do. Like, however you want to do it. It's the same thing. So 4x and 9x. So I have a positive 4 and a negative 9, so I'm going to get a negative 5. And then I have negative 6 and positive 5, so I'm going to get a negative 1. I have to add 1 to both sides. And I get negative 5x equals 30. Divide by negative 5. And x equals negative 6. Other equations, we're going to have some translations on these two. 15 times a number subtracted from 80. Okay. And then I have here 15 times the difference of a number and 80. I put these, they're very similar, but they're not the same. Okay. What I have is 15 times a number. Sorry, I'm going to put that in red. 15 times a number is being subtracted from 80. Here I have 15 times the difference of a number and 80. If you have some number times the sum or the difference, that puts parentheses. So if you see the sum or the difference, then you have parentheses around what happens next. So here, because I have the difference, this part is going in parentheses. So when we translate this one, I have 15 times the number. That's 15. What letter would you guys like to use?
T.
Okay, we'll use B on this one and T on that one. And then subtracted from 80, so that's 80 minus. Because it's going to be 80 minus 15B. Because we're subtracting from. And that's 25. So I have 80 minus 15B equals 25. I'm going to subtract 80 from both sides. And I'm going to get negative 15B is equal to negative 55? 45, 55. 55. Okay. I'm going to divide both sides by negative 15. Those do not divide evenly. Would you all agree they don't divide evenly? Okay. So B is going to be equal to 55 and 15 both divide by what? 5. So I'm going to divide this one by 5, and I'm going to divide this one by 5. And I'm going to get B is equal to 11 thirds. Okay. This one is 15 times the difference of a number and 80. Whenever you see the difference of a number or the difference of whatever comes first minus whatever comes second. Okay, so the difference of means first minus second. Just so you know what order to put them in. So this is going to be 15 parentheses t minus 80 equals 25. So you can see they're very different problems. I'm going to multiply that 15 in. Anybody have a calculator and want to do 15 times 80 for me real quick? Yeah, 1200. Okay, so I have 15t minus 1200 equals 25. So I'm going to add 1200 to both sides, which is going to give me 15t equals 1225. And I'm going to divide both of those by 15. Anybody want to check and see if that divides evenly? You got a decimal? Okay, so you got 81.6. Or, if you left it as a fraction, both of these divide by 5. So that would be 245 thirds. 5 plus, yeah, okay, or 245 thirds. On a problem like this, just give me the decimal answer. If it's an easier fraction, give me a fraction. If it's easier, if it's like this, give me the decimal. Quotient means divide. Okay, 2 plus the quotient of a number and 8. Okay, whenever you see the quotient of, it's the first divided by the second. Okay, so this is 2 plus some number divided by 8. Is the same as means equals. So 2 plus x over 8 equals 16. Here I have the quotient of 2 plus a number and 8. 2 plus a number and 8. This is the first. This is the second. So this is going to be 2 plus some number over 8 is equal to 16. Do you guys see the difference in those? Okay. So just be really careful. And if you ever, if you're stuck on the wording, let me know and I'll help you. So to solve this one, I'm going to subtract 2 from both sides. And I'm going to get x over 8 is equal to 14. And then I'm going to multiply both sides by 8. And I'm going to get x is equal to 112. I don't know my 14s. I know my 14's up to 3. Yes.
Oh, are we gonna do page 5 today?
Yes.
Okay.
Okay. So for this one, here we subtracted 2 first and then multiplied by 8. Here we're going to multiply by 8 first because that 2 plus the number is in the top, so it's separate. So I have to get rid of this 8 so that those will cancel out. So I get 2 plus x is equal to 16 times 8, so that's 128. And then I subtract 2 to get x equals 126. So that wording is really important, and if you get stuck or you don't know, just ask me. And variables on both sides. Okay? When you have variables on both sides, you want all the variables on one side, all the number on the other. So you want either x equals or whatever letter it is, or something equals x. It doesn't matter which one, they're the same. Just so long as you have the variable by itself. There are two ways to work these problems. You can either add and subtract to move things from one side to the other, or you can just pick them up and move them and change their sign. So I'm going to show you both, and you can pick the way that makes the most sense for you. Okay? Using addition or subtraction, first I'm going to move the variable. So I'm going to subtract it from both sides, because 3k minus 3k cancels out. And so I get 2 minus 3k, or not minus 3k, 2 plus 2k, 5k minus 3k is 2k, equals negative 6. Then I'm going to take this 2 and I'm going to subtract it from both sides. And I get 2k equals negative 8. And then I'm going to go crooked and I'm going to divide by 2 to get k equals negative 4. Now, I could have subtracted 5k from both sides and gone the other direction, and it would have been fine, and I got the same answer. As long as I did the addition and the subtraction and the multiplication and stuff correctly. Now, for some people that don't like this subtracting and adding variable terms thing, so what I can do, I can move anything from one side of the equation to the other. I can just pick it up and I can bring it over here. However, if I do that, I have to change the sign. So if you change sides, you have to change the sign. Think of it this way. When you go from one football team to another football team, you changed your jersey, right? Like if you wear, I don't know football teams, but if you wear like a blue shirt on this team, they're not going to want you to wear the blue shirt on the other team, right? So you have to change your sign.
So you keep the number.
You keep the number, you change the sign. Yeah.
Just like if we were to add or subtract.
It's the same thing, but some people like this visually better. So this becomes 5k minus 3k over here because I picked this up and I moved it. Then 5k minus 3k is 2k. So you see it's the same thing. It's just that some people, visually, it's easier to pick the variable thing up and move it than to subtract it from both sides. And you can do the same thing with the 2. I can pick it up and I can move it over here. I don't have to subtract it from both sides. But if I move it, it was positive, so now it's negative. So I get 2k equals negative 8, which will still give me k equals negative 4. So you're going to get the same answer. And you can do a combination of things. You can move the variable and change the sign, and then you could subtract the 2. Like whatever you're more comfortable with. Just so long as if you pick something up from this side and you put it on that side, you change the sign. But you're right, it's just like in the football jersey. You keep your number, but you change your color. I keep the number, but I change the sign. Does that help? Okay. Like, I don't care which one you use. If this one makes the most sense for you, then don't listen to me when I talk about this, and vice versa. Okay? Any questions on that thing? I'm going to do both methods. Here I'll subtract. I can either subtract the 5a from both sides, or I can add the 7a to both sides. Which would you like to do? Add the 7a. So I get 12a plus 2 equals 6. And I'm going to subtract the 2. I don't have a choice after that. You have a choice on the first step of which one you're going to move, but after that you don't really have a choice anymore. So I get 12a equals 4. I'm going to divide both sides by 12, which 4 does not divide by 12. But it does divide by 4, and 12 divides by 4, so I get 1/3. Or I can pick this 7 up and I can bring him over here. And you can even do this in the same step and bring that over there. So you see what I mean? Like I can do both of them at the same time and write the next line down. Or you can do it separately. So I still get 12a equals 4. So I still get a equals 1/3 because this part is the same. Good? Bad? Situation occurs. I don't have a choice. Like before I had a choice of which one I would move. If this is the situation, I have no choice. I have to move this variable over here. Because if I subtract 7w from both sides, I get negative 4w plus 2 equals, I moved it, it's gone. So I'm going to take that 3w away from both sides. It would equal 0, by the way, but that's a pointless step to take. So 2 equals 4w, divide by 4, and I get 1/2 equals w. Or if you don't like to write them this way, because some people have OCD, you can write w equals 1/2. It's the same thing. Okay. Here I have 1.3c and 3.3c, so I have to move this 3.3c. I don't have a choice. And I get negative 2c is equal to 2.8. 2.8. I'm going to divide both sides by negative 2. So c is equal to negative 1.4. You can either work with them or you can get rid of them. And getting rid of them is called clearing the fractions. And I will show you both methods, and you can pick the one you like the best. Okay, if I'm going to work with the fractions, the first thing I have to do is I have to have a common denominator. Because I cannot add or subtract fractions without having a common denominator, right? So what is my denominator going to be? 4. So I'm going to have to turn this x over 2 into something fourths. So because I multiplied this one times 2, I have to also multiply that times 2. So that becomes 2x over 4. So I have 2x over 4 plus 1 is equal to 1/4 x minus 6. Then I can subtract the 1/4 x from both sides. Well, 1/4 x is the same thing as x over 4, so I'm going to change that too to make it easier. So 2x minus 1x is 1x. So far okay? Did I lose you? Okay. So now I'm going to subtract 1 from both sides. And so I'm going to get x over 4 equals negative 7. And then I'm going to multiply both sides by 4 to get x equals negative 28. Or you can just say, you know what, I hate fractions. I don't want to deal with them. I'm going to clear them. We still need to know the common denominator. Which is 4. Now what I'm going to do to clear the fractions is I'm going to multiply the entire equation by the common denominator. Which means I'm multiplying every single thing by 4. So this is going to become 4 times x over 2 plus 4 times 1 equals 4 times 1/4 x plus or minus 4 times 6. Okay? This is why we do this. 2 goes into 4 twice, so that gives me 2x. 4 times 1 is 4. 4 goes into 4 once, so this just gives me x minus 24. I don't have fractions anymore. So if you multiply the entire equation by the common denominator, you get rid of all of the fractions. Now I have to multiply everything though, because just getting rid of the fractions and keeping a 1 and a negative 6 is no longer the same equation. So whatever you do to one side, you have to do to both sides. And if you're multiplying by a whole equation, you have to multiply every single term in the equation. Okay? After that, I can subtract x. So I get x plus 4 equals negative 24. I can subtract 4. And I get x equals negative 28. Preference. You can solve it with the fractions. You can solve it without the fractions. That doesn't matter to me. Okay, so multiply these by 3 times 2 times 3. And I get 2 24ths plus 9 24ths y is equal to 10 24ths plus 15 24ths y. Are we having fun yet? Okay. Do you want to subtract the 15 24ths or the 9 24ths? Okay, we'll subtract 9 24ths. 24ths. Okay, so I get 2 24ths is equal to 10 24ths plus 15 minus 9 is 6. Okay. Then I'm going to subtract 10 24ths from both sides. And I get negative 8 24ths is equal to 6 24ths y. And I can multiply both sides by the reciprocal, or I can do the multiply by 24 divide by 6 thing. Which would you prefer? One step or two? Anybody? All right, I'm going to multiply both sides by 24 then, because I like that better. And I'm going to get negative 8 is equal to 6y, right? Because these 24's canceled and those 24's canceled. So then I'm going to divide by 6. And I have negative 4/3 equals y. Now, try to clear the fractions. We're going to multiply everything times 24. Okay, so I get 24 times 1/12 plus 24 times 3/8 y equals 24 times 5/12 plus 24 times 5/8 y. Okay, 12 goes into 24 twice, 8 goes into 24 3 times, 12 goes into 24 twice, 8 goes into 24 3 times. So 2 times 1 is 2, 3 times 3 is 9, 2 times 5 is 10, 3 times 5 is 15. Do you guys notice a pattern here? 2, 9, 10, 15. 2, 9, 10, 15. Only we don't have to deal with the denominators. Subtract 9y from both sides. 2 is equal to 10 plus 6y. Subtract 10 from both sides. Negative 8 is equal to 6y. Divide by 6. And I get negative 4/3 is equal to y. Parentheses and variables on both sides, you have to do that first step, which is to distribute. That's why I had said if necessary. because sometimes it's not necessary, like it wasn't necessary in the last examples. Then you're going to collect like terms if necessary. Same steps. And then you're going to add or subtract if necessary. And then you will multiply or divide if necessary. Okay. So I'll distribute that 7 and this negative 2. 7n minus 7 is equal to negative 6 minus 2n. Add 2n to both sides. 9n minus 7 is equal to negative 6. Add 7 to both sides. 9n equals 1. Divide by 9. They don't divide. Distribute the 1/3. Remember when we do that, 3 goes into 24 8 times and into 12 4 times. So I get 30m minus 18 is equal to 8m plus 4 minus 8m. 22m minus 18 is equal to 4 plus 18. 22m is equal to 22. So what's m equal? But I'll work it through quickly, but I'll still tell you the steps. So I'm going to distribute this 3 first. Okay, and then I'm going to collect like terms. And then I'm going to subtract 5x. And I'm going to get 5 equals negative 12. What do you guys think? Does 5 equal negative 12? Anybody? Okay. No, 5 does not equal negative 12. If you get this situation where your variables, once you've subtracted, have gone away, and you get a false statement, there are no solutions. There is no value of x that would make that original equation true. So this is your answer. Okay? And here I'm going to multiply that 3 in. I'm going to get 6b minus 3 minus 7 is equal to 6b minus 10. So 6b minus 10 is equal to 6b minus 10. I'm going to subtract 6b. And I get negative 10 equals negative 10. Why, yes it does. If this happens, your answer is all solutions. It's all real numbers. Every real number. I could plug in any number and it will be true. So if you work out a solution and you lose the variables, we lost the variables, right? And you get a false statement, your answer is no solutions. If you get a true statement, your answer is all real numbers.